Judgment calls. Anytime you're doing an engine, especially if you're doing one for yourself, you're going to have to look at things and assess whether or not they can be reused or not, or what steps you want to take. When you're doing it for a customer, it's a little bit different. When you're doing it for a customer, you make as few judgment calls as possible. If in doubt, just replace. You don't know how they're going to use it. You don't know what their expectations are. You don't know anything about the future of this engine. So therefore, you cut no corners and you do everything by the book. But by the book doesn't always necessarily work when you're just trying to put something together for yourself to run around with. And this is where we're at with this engine now. I know I said we were going to pull the pistons out in this installment, but I'm going to save that for the next. Because there were several comments that I want to address from the last episode, and I want to show you some of the judgment calls that I'm making and explain why I'm making them. So let's first go back to the last video and let's talk about comments. Something that popped up a couple of times was people quoted, we showed the height difference of the valves in the head, and people quoted the height difference in the intake and the exhaust valve on this particular engine. Now this is something you got to keep in mind. This is not about rebuilding a 4.0 Jeep engine. I just happen to be using this 4.0 for myself because I need one for one of my Jeeps. So I'm doing this myself, and I'm doing it with less than zero performance aspects to this build. All I care about is that it's going to loaf down the highway at 2,500 RPM for days on end and not give me any trouble. That's all I'm looking for this thing. But I'm trying to cover as many bases. I'm using a very broad brush and using this as an example. So back to what I was saying. A lot of guys quoted the height difference of the valves, and that because I pointed out that a sunk valve, the exhaust valve sunk, would leave the stem higher. But here's what you have to understand. When valves are measured, they're measured from the face to the tip. So from the face to the tip is one measurement, but that's not what we're going by. We're going by from the seat to the tip. And that's what counts in our application. The seat, regardless of the overall length of the valve, the seat to the tip distance should be identical, intake and exhaust. Why is this? Because the exhaust valve is going to have a slightly thicker face. So therefore, if the face on the exhaust valve is 10 or 20 thousandths of an inch thicker than that on the intake valve, this distance to this distance is going to be different. But like I said, we're not concerned with that. We're concerned with the seat to the tip and where it sits in the head. It should always be the same. I can't think of any example where the tip height of the valve is going to be different from intake to exhaust. So you can use that as a fairly good guide, what I showed you, laying a straight edge across and see if any of the exhausts are up higher than the intakes. Right. That was the one thing. Now, going back to the particulars of this engine, I pointed out that on this head, the first two intake ports were loaded with sludge. And a lot of you guys were like, oh, that's from the PCV system. That's oil being recirculated. Well, here's the intake manifold that came off of that engine. Okay, and here are your main vacuum ports. I'm not sure which one is for the PCV or which one is for the power brakes, but you've got two here and you've got one here. And as you can see, these are the two. This is the number one and number two intake runners. Here is where, if it was a blow-by or a bad PCV valve situation, here's where the oil would have entered, and therefore the closest runners, all of these runners are the same. They have a common plenum, but all of the runners are essentially the same. So if it was an oil blow-by situation, it wouldn't have gathered up at the front of the engine. It would have gathered at the ports closest to the vacuum ports, or closest to the PCV. So that's not the question. All right. Head bolts. Now, one of our viewers threw something in there that's just so simple and so obvious. I never thought of it, but I will use it from now on. And he says, just take a nut and thread it onto the head bolt. And if the threads get tighter as you go along, it means that they're distorted and therefore stretched. Yes, brilliant. I know that doesn't talk about the shank, but it will account for stretch in the thread area of the bolt. So that's a good one. Now, many people in the comments of that last video said, well, just throw them away. You know, head bolts are better. It's good insurance. Just throw them away. All right, that doesn't work in every situation. And here's why. Well, a couple of reasons why. The first is that head bolts are not cheap and available for every engine that you're going to come across. We may have somebody following this series here that's building a, I don't know, an old AMC motor or whatever it happens to be. Well, that is an old AMC motor. But whatever it happens to be, those parts may not be available. And so therefore, it's not just cheap insurance. You know, I don't want to put it in people's minds that, yes, you just automatically throw these things away and get new ones. Now, that is true of some engines. And if you bother going through the factory service manual of these, and like, okay, let's just say the 4100, which is like the notorious example for head bolts and threaded boss issues. And all right, you throw them away. All of these torque to yield bolts are throwaways. Some of the ones from the 80s and the 90s, like for instance on these Jeep engines, they tell you that you can use them, reuse them once, and then you got to throw them away. Okay, and then when you get back to older engines, you get back to stuff that was built during the 60s and the 70s, the early 80s, let me tell you something. Those bolts are reusable over and over and over and over again. I have no idea what the metallurgical properties are of these bolts that make them as strong as they are. I'm not a metallurgist. But what I can tell you is that for eons, nobody ever thought about replacing head bolts just as a matter of regular course. And just for my own satisfaction, as if I haven't already memorized this thing, I cracked open the service manual, the 1967 Chrysler service manual, and here's where they're talking about head bolts, and they talk about, you know, the disassembly and the reassembly of the engine, and absolutely nowhere in there is it even mentioned to measure the bolts for stretch, right, or anything like that. It's just take the head bolts out, put the head bolts back. It depends on what you're working on, so you have to make judgment calls as you go along to know whether or not certain things need to be replaced, certain things should be replaced, or certain things are just fine and good to go. So now let's go back to our engine and let's talk about some of the judgment calls that we're making as we go along. So you guys are well aware, you've got to be aware, of all of the issues that have been happening with cams and lifters lately. It's a mess. It's a wild card. Now, in the old days, when you rebuilt an engine either for yourself or a customer, you never even thought about it. You took the cam and the lifters, whatever was in there, and you throw it away. And then you either replaced it with a new stock spec cam and lifters, or you go for high performance, whatever happened to be. But it was a no-brainer. You just throw it away. It's cheap. It's going to be like $150. You get a cam and lifters and you throw it in there. Okay, it's not like that anymore. First off, those parts aren't as cheap as they used to be. But that's the least of it. The biggest problem is you don't know what you're getting or where it's coming from. So on my engine here, I made the judgment call that if the lifters look good, I'm going to reuse this cam and lifters. Because again, this is not a high performance engine. All this thing has to do is just roll down the road relatively trouble-free for the next 100,000 miles, and I'm thrilled. I got my money out of it. All right, so I pulled the lifters out of it. Now I want to point out a couple of things. Since I decided I wanted to save the lifters, I made myself a little cardboard boat for these things, a little cardboard carrier. And just so that they never get screwed up, I never have any question what's front or what's back, I marked it on the package, on my little cardboard boat, and I turned the number one lifter right side up. All of the rest of them are upside down. All right, so, but for these purposes, I just want to show you guys the differences. Let me get this thing where so you notice that all of these lifters have a very defined round wear pattern, but also look at how different they are. These are adjoining lifters, but look at the difference in the patterns. Okay, now these are all good. You can see that they've all been rotating. They're all doing what they're supposed to do, but they're all different. And that is why, if you are going to reuse cam and lifters from an engine, you make sure those lifters go exactly back to the lobe that they came from. So I have total confidence in this, seeing the very clearly defined circular wear patterns on all of these lifters, and none of them are dished, none of them are concave. I laid a straight edge across and checked. They're all good to go. So I am going to reuse this Cameron lifters and not have to worry about, is this thing that came from East Bongo Squeegee, is this thing going to live, right? Did they give me a licorice or did they give me a camshaft? I don't know. So I'm going to reuse this. I'm not saying for you to reuse yours, but it's a judgment call that you're going to have to make. And again, a lot of it has to do with the expected use and the expected life expectancy of this engine. You could also say the same thing for like valve springs. This engine will never spin higher than, let's say, 4,500 RPM. I mean, 5,000 RPM max. It's going into a car that I use as a daily driver, and it's just, I just motor it down the road. It's never going to see any type of high performance use or expect any type of high performance use. So therefore, I will reuse these valve springs. They all feel like they all look good. They pass a visual inspection, and they all feel like they've got proper tension. I cannot move any of them with my hand. And to me, that's enough. That's my judgment call on these springs. That's not saying that if you're building a slightly high performance engine, or you're going to bigger cam in it, spin it higher RPM, yes, we definitely replace those valve springs. But for me, for this engine, they're going to be just fine. And I think the intent of this video series on building your first engine or rebuilding your first engine job, I think the vast majority of people who are viewing this are understanding that, that we're using this engine as an example, and this isn't a textbook, but what I'm doing is I'm explaining all of the pros and cons and the variations as I go through my own engine. All right, so another judgment call, and I said it in the last video, was that you're miles ahead if you just go get yourself a remanufactured head. And I stand by that. On this one here, I am going to go through this one myself. I priced them out. They're in like the $400 to $500 range. The cheaper ones, well, I don't really want to deal with one of the cheaper ones. This is one of those situations where you get what you pay for. You go for a bargain basement reman, $350 or whatever, and you're really getting a bargain basement reman. So it's not the cost of doing it that's turning me off. It's just the fact that I want to do it myself, and I'll probably have. I know I've got to replace the exhaust valves. I know that it's going to need a seat or two, and it's probably going to need a couple of guides, if not all of them. I know that my machine work and parts costs are going to be greater than if I just bought a reman, but this is the way I want to do it. And also, it'll give me a chance to actually show you guys taking apart a head and checking out the guides, checking out the seats and all that. Okay, and two other things, going back to the comments from that last video. The first is that I've never done one of these 4.0s before, so I'm not familiar with its idiosyncrasies. But one of the things I showed was that there was blockage over here. But actually, as it turns out, one of the viewers pointed this out, there is no corresponding hole in the deck or the head gasket for these holes. They're just so sand can be removed from the casting as it's being made. So it would be okay to find buildup in these areas. Thank you for that. The other thing was the first head bolt I pulled out of this engine was gacked with goop, for lack of a better phrase, right? And a number of viewers pointed out that particular bolt on this particular engine goes into a water jacket. Now, I mean, I've done many engines over the years where where the bolt goes into an open hole that's open to the water jacket, and you'll use thread sealer on the threads. In this particular one, the whole shank of the bolt was gacked up with the stuff, and I was curious what that was. Well, here's the reason for that on these engines. So here's the bolt hole, and here's the water pump. And the bolt hole is actually open to the water pump. So I imagine in this situation, just putting some thread sealer on the threads themselves of the bolt is probably not quite enough. And so they must, on the assembly line, they must just take that bolt, whip it around in sealer, and shove it in the hole. And that's what I ended up with here. All of the rest of these are close to the water jackets. But like I said, this particular one is not only open to the water jacket, but it's directly in the water pump. So, yeah, I could see where that would take some extra consideration. And evidently, that bolt hole is also torqued lighter than the other ones. That head bolt is torqued lighter than the other ones. I don't know. I'll find out. I got to look into that. But that's that. So I think I covered everything I wanted to cover on this. The next time around, we'll do what we were supposed to do this time, and we're going to knock the pistons out of it. And again, make judgment calls. Can we hone this block, or is it going to have to be bored? Can we save the pistons? How many of the pistons are we going to replace? Just the one or two bad ones, or are we going to replace all of them? It's all a matter of judgment calls, and we'll go through all of that as we go along. So that's it, guys. I hope you got something out of that one, and I'll see you tomorrow.